Great. Okay, so the last one I want to look at is this plane strain. I'm going to redo this video because what happened in the previous video, I started deleting this bottom two. As I was thinking, I was deleting the components with a Z in them, but the reality is the bottom one is gamma XY. So the components I need to delete are any of the, well, not delete, but what will set to 0 in this plane strain condition, because we have an infinitely thick body. So there's nothing out of the plane, no shear or no normal. So any gamma involving a Z or epsilon involving a Z, those strains will be 0. Not the stresses, but all those strains will be equal to 0. And so the ones that I needed to delete was these two. Okay, so this one and this one. Okay, so let's do that version and make sure. But what we'll see is when we do this, that the shear stresses will just follow to be 0, because they are just directly related with G to gamma. Remember, gamma is twice the epsilon xy or yz, or sorry, yz or epsilon xz. And then essentially what we have is that the sigma zz will be something Poisson epsilon xx epsilon xy multiplied by what's in front of that conservative relation. But this is essentially what we'll see, what we'll recover. And this is what I just want to quickly redo the video for. As the previous video, I was killing the last two things, but I should have killed these two to make them 0. Okay, so let's get back to going that. And for that, I'm going to go back to this whiteboard version. Okay, let me see if I can see what's going on here. Okay, so that's what we have. So let's start off with the whole thing again, the big system. And then from here, we know now with the plane strain condition, because we have a very thick body, nothing, no movement out of the plane, everything just in the plane. Okay, so this time around, I'm just going to make sure I look carefully what I'm doing. So here is the one, no, that's the wrong one again. There's one, there's the two shear stresses, and we know essentially now that it's these shear strains that we have, and that they should be equal to 0 and they should be equal to 0. Okay, and if they are equal to 0, each of these shear strains will multiply with its respective single component, because they're just directly related to the shear stresses, so these will just follow directly to be 0. Nothing funny, really quite simple. Okay, the last thing that we need to that we know is equal to 0 in this plane strain condition, again, is the normal stress out of the plane, the normal to the plane. Nothing will move there. This will also be equal to 0. And if I look then essentially at what's going on here, if I look at this last expression, this equation here for sigma zz, I see that essentially if I multiply out this with this, I can write down an expression for sigma zz directly. So sigma zz is equal to, what is it? It is essentially Poisson and Poisson will multiply with the epsilon xx, epsilon yy. So that will be Poisson will multiply plus epsilon yy. Okay, that's that. And then essentially I have all this jazz in front of here, this stuff in front of here, and this I'm just going to call, for simplify this stuff that we see here, that E over what is it, 1 plus mu, 1 minus 2 mu, I'm just going to call E star. Okay, so let's call that E star, and then I can say this would be just E star multiplied by that for epsilon zz. And now I've used this equation, so this equation I can essentially take out of the system here. So let's just see where I am. So this equation I've used now as a separate afterthought, and because everything in this column here, everything with epsilon zz in this column here, yeah, will multiply with zeros, I can just delete this column out, because it's just like, remember, every variable will multiply with each column, this column, and then this 0 will multiply with each column. If I just say 0 times a column, I might as well just take the column out. So that's why the system then reduces to a 3 by 3 system, where the only things that we are solving for are essentially, and the only strains that are not 0 are gamma xy, gamma yy, gamma xx, and that will result in stresses that are non-zero, tau xy, sigma yy, sigma xx plus sigma zz. Okay, so this is not 0. Critical. Please make sure you follow this, because if you were to calculate, for instance, von Mises or Tresca, yeah, and you don't consider this, you do plane strain, and you don't consider this to be equal to some value, you'll do it wrong. Also for plane stress, if you do Tresca, and so this is if you were to do plane stress, Tresca, then you know sigma ZZ is equal to 0. You still have to know that, because it might be that your other principal stresses, or your sigma XX and YYs, or your principal might be in the, let's say your principal stresses might be positive, then your slowest principal stress will be the sigma ZZ. So it's important to make sure that you don't forget about the fact that they are there, they do have values. In plane stress, it's sigma equals 0, 0, and plane strain, we essentially have it as then is sigma ZZ equals to E star Poisson sigma epsilon XX plus epsilon YY. Okay, this is important to take note of. So essentially the stresses side, there are 4 non-zero stresses for the plane strain, and when it comes to the plane stress condition, we essentially have 4 non-zero strains, because then we'll have essentially gamma ZZ as a non-zero strain. Okay, so hopefully this gives you a full big picture of what's going on, and yeah, this is just to replace that other video where I mistakenly started deleting the last ones. Okay, so that was just inconsistent. Okay, hopefully this gives you good clarity, and all the best for Monday or for Tuesday. Thank you.